Hi students, in this video we're going to look at how to take matrices to powers. So what we're going to do in this video, we have to determine the value of matrices taken just to positive whole powers. So no negative powers, no fractional powers, we're just going to take matrices to positive whole powers and work out how to do that by hand. A few things to remember, so the definition of powers, so for example, x squared, that just means x times itself twice. If we're talking about 5 to the 4, we say we're taking 5 and multiplying it by itself 4 times. That's what powers mean. We just keep repeatedly multiplying by the same number according to how many the number in our power. The other thing you'll have to know is matrix multiplication. That was covered in an earlier video. Right, so powers of matrices can be calculated basically just by using matrix multiplication that we've already covered in a previous lesson. Now, each multiplication step needs to be carried out one step at a time. Now, what that means is if you want to work out the value of a cubed, for example, first you have to work out the value of a squared, and then once you have a squared, then work out your value of a cubed. So you can't just go straight from one matrix to a cubed. So start with a and finish with a cubed. You have to start with a, then get a squared, then get a cubed. And we'll talk about why in an example. Now note that it's also only square matrices that can be taken to powers in order for matrix multiplication to be even possible in the first place. So let's consider why that's the case first before we go much further. Let's say matrix A has an order of 2 times 5. That means matrix A squared is going to be A times A. We'll have a 2 times 5 matrix, another 2 times 5 matrix. Our numbers in the middle are not the same, so that can't be done. A squared can't be done at all there. Let's say we have another matrix B, which is 3 by 3. If we have B squared, that's the same as B times B. Our order will be 3 times 3 for our first matrix, 3 times 3 for our second, and look at that. The middle numbers are the same, so we can do matrix multiplication here. And when we do it, the order of our answer is going to go back and be 3 by 3 as well, just like the matrices we started with. Alright, so what we're going to do is, first of all, considering the matrix A equals -1, 2, 3, 2, we're going to work out A squared. So how we're going to start that off is recalling A squared is just equal to A times A, and then multiply these matrices together. Now I might multiply these matrices together a little bit differently than I did in the previous video, just to give you a different way of expressing and showing how you do your matrix multiplication. Now the steps are still all the same. We first of all take our first row and multiply it by our first column. But rather than work it out to the side, we're just going to put it all straight into our matrix from the very start. So what I'm looking for here is first element times first element. So -1 times -1 gives me +1. Then 2 times +3 gives me 6. And that's going to go in the position 1, 1 because it's first row and first column. Now if I'm doing first row and second column now, here I will put that in the next cell across. So once again we'll have -1 times +2, which is just -2, and then +2 times +2, which gives us +4. That's in our first row, second column. All right, moving on to our third row. We'll do second row times first column, and then matching up our elements again. So that'll be 3 times -1, which will be -3, plus 2 times 3, which is 6. And then finally, in our last element, we'll have second row times second column, So that will be 3 times positive 2, which gives us 6, and then 2 times positive 2, which gives us 4. And all of those values I can work out. 1 plus 6 is 7, negative 2 plus 4 is positive 2, negative 3 plus 6 is positive 3, 6 plus 4 is 10. And that's how we can work out a squared. Right, now let's consider how we're going to work out a cubed. So what we need first is to have actually worked out what a squared is. And the reason is because when we think about a cubed, that's just a times a times a. Now, what we can do first is these two matrices multiplied together, which is a squared. And then once we have a squared, we can just times it by a again to get a cubed. So I'm thankful we've already got a squared. We did that on our last slide. And now we can just multiply it by a. And again, applying the same rules as before. We've got our matrix here. We'll do first row times first column. So that'll be 7 times negative 1, which is just negative 7. And 2 times 6. So 2 times 3, which is 6, and then continue to work our way along. So we'll do first row this time, multiplied by second column. So that'll be 7 times 2, which is 14, plus 2 times 2, which is 4. And then we'll move on to our second row. So second row times first column, we will get 3 times negative 1, that's negative 3, 10 times 3, that's 30. And then finally, we'll do second row times second column. And so there we'll get 3 times 2, which is 6, plus 10 times 2, which is 20. And then adding up all those numbers, negative 7 plus 6 is negative 1, 14 plus 4 is 18, negative 3 plus 30 is 27, 6 plus 20 is 26. And there's our value, or there's our matrix for a cubed. Just do find out a squared first, and just multiply by a again. To get a to the 4, we'll just get the answer we just had and multiply it by a again. It's a long process, but that's the best way to do it. Alright, so after watching this video, you should be able to determine the values of matrices taken to positive whole powers.